I hope everyone is ready. Can you still hear my voice clearly? Can you still hear the radio? Okay, good. Okay, so today we are going to continue with our standard solution subtopic 6.6. If we can recall, last class we have go through the meaning of standard solution, and we also have go through the preparation of standard solution from solid substance and its calculation. Okay, so preparation of solid substance from solid substance ni macam nak buat air Milo lah. Contoh macam nak buat air Milo. So, macam mana kita buat air Milo? Kita add solid Milo. Macam tu. Itu adalah preparation of standard solution from solid substance. And you have to know how to calculate the mass of solute. Okay, you have to know how to calculate the mass of solute yang perlu kita gunakan that we need. Okay. And before that, quickly, can we recall the meaning of standard solution? Do you still remember what is the meaning of standard solution? Can I have Ainul Farhani? Can you give me the answer? What is the meaning of standard solution? Ainul Farhani? Are you here? No, can I have Chelsea? Good, thank you very much, Chelsea. So solution with a known concentration. Okay, when we know the concentration of the solution, then it is called a standard solution. So today we are going to continue to in preparation of standard solution. Still in preparation of standard solution, but we are going to see how to prepare a standard solution from stock solution. Okay, kalau yang ni kiranya macam kita buat air sirap. Macam mana kita buat air sirap? Yes, kita letak sirap. Okay, kita tak letak solid sirap kan? Kita letak sirap pekat. Betul? Yang dijual dekat dalam bekas. Yes, cordial or cordial. Good, thank you. Ataupun cordial, dia dipanggil cordial. So that cordial is also known as stock solution. Okay, kenapa cordial ni dipanggil stock solution? Sebab dia concentrated. Apa maksud concentrated? What does concentrated mean dalam bahasa Melayu? Pekat. Yes, pekat. So, kita tahu bahawa stock solution dia mestilah concentrated. Tulisan saya macam ni. Can you read my writings? Can you still read my writings? Okay, good. Kalau tak faham boleh tanya, okay? Alright, so concentrated. Stock solution is concentrated. So, hari ni kita nak belajar macam mana nak buat standard solution from stock solution. And, okay, proses ini ada nama. Method ini ada nama. Namanya adalah dilution process ataupun dilution method. Okay, sebab apa? Sebab kita hanyalah nak mencairkan benda. Dilution maksudnya pencairan. Proses pencairan. So, daripada pekat kita cairkan dia. Sebab tu nama dia dilution process. Dan sebab tu juga stock solution tu mestilah pekat. Concentrated. And this step also have calculation. Kenapa kita ada calculation? Apa yang kita nak calculate? Kita kena calculate volume of concentrated solution yang kita kena guna. Okay. Contohnya nak buat air sirap. Hari tu saya minta tolong Chelsea buat Milo pen kan. Hari ni saya minta tolong, let's say saya minta tolong Alisa pula. Alisa, tolong buat air sirap untuk saya. Kemudian Alisa tanya, how much syrup do I need to add, teacher? Berapa banyak sirap yang saya kena bubuh? 2 sudu ke, 10 ml ke, 50 ml ke? Itu yang kita kena kira. Sebabkan kita guna concentrated solution. So hari tu kalau nak buat from solid substance, kita kena tahu berapa gram Milo, berapa gram solute. Hari ni kalau kita nak buat daripada stock solution ataupun concentrated solution, kita kena tahu berapa volume of concentrated solution tu. Clear? Okay, good. So bersemangat tak nak tahu ni macam mana? Semangat. Bagus, kena semangat. Okay? Alright, so jom kita tengok. Okay, this is the recap from last class. What is standard solution, meaning of standard solution, and then this one, preparation of standard solution ada 2. So we are done with this one, process calculation guna formula ni. Now we are going to see from top solution the process and the calculation, and this is the only formula that we should use for dilution. Okay. Volumetric flux, we are still going to use volumetric flux, and then this is last class punya notes. Okay. Here, okay, this is today's class. So now we are going to prepare a standard solution from stock solution, and it is called dilution method. First of all, you need to know what is dilution method. So dilution method is basically we are adding water. Kita tambah water sahaja sebab namanya pun dah pencairan, proses pencairan. Bila kita nak cairkan sesuatu, kita hanya cuma perlu tambah air. So add water to a concentrated standard solution. Mesti kepada larutan standard yang pekat. Standard solution. Why must we use standard solution? Siapa boleh bagi jawapan? Kenapa standard solution? It must it have relation with the meaning of standard solution. Good, because we have to know the concentration. Good job, thank you. Okay, so how are we going to, so dilution method is basically kita addkan water kepada solution yang pekat, but mesti ada satu benda lagi. Larutan yang pekat tu mestilah kita tahu concentration dia. So concentrated standard solution. Kalau tak tahu kepekatan dia, macam mana juga kita nak tahu berapa banyak yang kita kena tambah? Macam mana kita nak kira kita punya concentration yang kita nak hasilkan? Okay, so kita nak prepare satu standard solution yang kita tahu known concentration. Kita kena tahu concentration dia sebelum, okay, yang pekat tu berapa. To produce a more diluted solution, untuk menghasilkan larutan yang lebih cair. Lebih cair pun known concentration. Sebab itulah kita nak hasilkan, sebab itulah namanya standard solution. So standard solution je mesti known concentration. So dilution method is basically adding water to a concentrated standard solution to produce a more diluted solution. So, boleh faham maksud dia? Boleh, good. Alright, next one. Ini adalah gambaran dia. Contoh macam kita ada concentrated solution, maksudnya sirap lah. Contoh sirap pekat. Okay, sirap dalam tu, okay, sirap pekat biasanya dalam satu bekas ni kita bubuh sikit je. Okay, so adalah, macam mana sirap tu pekat, dalam tu adalah sirap yang concentrated. Maksudnya adalah 5 molekul sirap dalam tu. Contoh. Okay, air katakan ada 10 cm3 saja. Okay. Kemudian kita add distilled water. Ini adalah dilution method. Kenapa dilution method? Sebab concentrated solution ini also known concentration. Macam mana kita known concentration? Kita kira lah. Okay, let's say ada 5 mol. 5 mol of syrup. So kira concentration dia 5/10 bahagi 1000 0.05 is it? 0.005 500 500 sebab concentrated 500 mol per dm cube. Ini. Kemudian apa yang kita buat? Kita tambah air. So when we add water, adakah solid bertambah? Solid bertambah tak? Solid. Solid tak bertambah. Solid the same. No, nampak tak? Sirap tu masih lagi 5 molekul. Allah. Where is it? Okay. Solid tu masih lagi 5 mol, betul tak? Masih ada 5 lagi sirap dalam tu. 1, 2, 3, 4, 5. Apa yang kita tambah? Apa yang bertambah? Yes, yang bertambah Yang bertambah hanyalah volume of water. Volume of water sahaja yang bertambah. So let's say kita sekarang nak kira concentration yang baru. So new concentration sama dengan 5 mol divide by, okay, katakan kita tambah 80 cm cube. Kita tambah 80 cm cube. Tadi ada 10 cm cube. So berapa volume baru sekarang? Hello? Hello? Hello, can you hear me? Ulang. Okay, sekarang ni we are going to calculate the new concentration of the diluted solution. So because of the because of the number of mole of the solute tu masih sama tadi, okay, semua orang setuju number of mole of solute sama sebab kita tak tambah solute pun. So 5 mole divided by the volume of water. So volume of water sebelum ni 10 cm cube, kita add 80 cm cube. So what is the new volume of water? 90, good. 90 over 1000. So berapa new concentration dia? .556 mol per dm cube. Nampak tak? Okay, so this thing you need to understand. Because when the water is added, the concentration differs. Betul tak? Concentration dia berubah. Daripada 500 mol per dm cube jadi 55 mol per dm cube. Dia lebih cair, nampak? Betul? Setuju? Okay, setuju, betul. But you have to know the number of mole of solute are the same. Okay, number of mole of solute tu masih sama. Daripada gambar pun kita nampak. 5 mol kat sini, sini pun masih 5 mol. Sebab kita tak tambah pun solute. Kita hanya tambah water. So you have to keep that in mind. The number of moles of solute are the same. Okay? Boleh? Okay, it occurs every time. Setiap kali kita buat dilution method, number of mole of solute ataupun mass of solute sentiasa sama. Sebab kita tak tambah solute dah, kita hanya tambah air. So volume sahaja yang berubah. Kenapa ini penting? Sebab dia akan menentukan cara nak kira. Macam mana kita nak kira nanti. Okay? So, kalau kita recap, if we recap our formula for concentration, we know that concentration in mole per dm cube adalah number of mole of solute divided by the volume of solution. Okay, yang tadi kita guna. And ada juga formula nombor 3 untuk cari number of mole is equal to molarity of the solution times with the volume of the solution divided by 1000. Dapat cari number of mole. Betul? Ingat lagi formula ni? Okay, so tak ada benda baru. Semua masih sama. Masih faham. So, using this concept, sekarang ni kita nak adakan formula. So, kita tahu bahawa number of mole before akan sama dengan number of mole after. Betul? Ini kita dah tengok tadi. Sebelum 5 mol, selepas pun masih 5 mol. So, kita tahu bila kita buat dilution method, when we use dilution method, the number of mole of solute before will always be the same as the number of solute after dilution. Setuju? Okay, good. So, daripada situ, kita akan dapat kita punya formula. Jadi, when we know that the number of mole of solute before must be equal to the number of mole of solute after. Ni semua dah setuju tadi kan? So, formula untuk dapatkan number of mole adalah mv/1000. So, number of mole before is equal to number of mole after. So, kita potong dan 1000, kita akan dapat formula ini. Number of mole before sama dengan number of mole after. M1V1 equal to M2V2. M1 adalah molarity of stock solution before dilution. V1 adalah volume of solution before dilution. Sebab nak kira number of mole before. Okay. Dan ini adalah formula untuk number of mole after. So, dia guna molarity. M2 adalah molarity of after dilution, while V2 adalah volume of solution after dilution. Boleh faham tak formula ini sekarang? Bolehlah sikit-sikit? Yes? Seribu tu kan kita guna untuk because to change from centimeter cube to decimeter cube sebelum ni. Remember? Okay. 1000 tu untuk tukarkan centimeter cube to decimeter cube. If the solution already in decimeter cube, then you don't have to divide by 1000. Tu sebelum ni punya. Any more questions? Oh, good. So, we can proceed now. Now, we are going to prepare a standard solution from stock solution using dilution method. So, our aim now is to prepare 100 centimeter cube of 0.2 mole of dm cube of sodium carbonate. So, our material adalah still distilled water and mestilah ada stock solution. So, this is our stock solution. Ataupun our concentrated standard solution. Okay, mesti guna standard solution mesti known concentration. Concentration dia mestilah lebih tinggi daripada concentration yang kita nak hasilkan. See, lebih tinggi, 1.0 mol. Okay, so our apparatus kita akan guna volumetric flask juga. But the volume of volumetric flask mesti ikut volume of standard solution yang kita nak hasilkan. So, kita gunalah 100 cm3 of volumetric flask. Janganlah guna volumetric flask 250 cm3 lagi. Boleh faham? Okay. The next one, apparatus yang special untuk dilution method is pipette. Do you still remember what pipette is? Okay. Pipette adalah measuring tools yang ada dekat tengah-tengah ni. Macam tu pipette. Dan kita guna pump selalu dekat atas. Okay, untuk dapatkan exact volume of solution. Kita tak guna measuring cylinder. Oh, sorry. Tak nak guna kat sini. Sekejap. Kita tak nak guna measuring cylinder. Why? Kenapa kita tak guna measuring cylinder? Can someone tell me why? Why we are not using measuring cylinder? Why we use pipette instead? Good, okay. So that we can get a more precise ataupun accurate volume. Okay, pipette memang untuk dapatkan accurate volume. Measuring cylinder is not that accurate. Okay, and then we are going to use the same thing lah. Filter funnel, beaker, glass rod. Glass rod tak perlu, sorry. Filter funnel pun tak perlu sangat. Dropper. Okay, beaker dan seterusnya. Okay, so now untuk kita buat air sirap yang cair. So kita nak guna calculation. Kita nak calculate berapa banyak air concentrated sirap yang kita perlukan. So we are going to calculate the volume of stock solution needed using this formula. Okay, so untuk kira volume of stock solution needed, yang mana satu volume of stock solution needed? M1 ke V1 ke M2 ke V2? Volume of stock solution needed tu dekat M1 ke? Stock solution needed. Yes, ia adalah bahagian ini. V1, volume yang sebelum kita dilutekan. Inilah dia. Volume of stock solution needed adalah V1. Okay, so kita nak kira. So daripada formula itu, M1 V1 equal to M2 V2. Kita nak dapatkan V1. So kita kekalkan V1 kat kiri. So kita punya formula now is M2 V2 divided by M1. So what is our M2? M2 is molarity after. What is the molarity after yang kita nak? Molarity after dilution, iaitu molarity yang kita nak. Berapa? Good. Okay, ini yang kita nak. So this is M2. Alright, so 0.2 M. Darab dengan V2, volume after. So volume after kita berapa ya? Yang mana satu? Volume after. Good. So this is our volume yang kita hendak, V2, iaitu 100. 100 divided by M1. Which one is our M1? Molarity before. Good. This is our M1. 1.0. So tekan calculator. 0.2 times 100 divided by 1 is equal to 20. So now we have 20. 20 apa unit dia? Siapa tahu? Kita tengok balik. 20 ni adalah V1. V adalah volume. Yes, V adalah cm3. Okay. Kenapa cm3? Because our V1 dalam cm3. So V2 kita pun dalam cm3. If V1 is in decimeter cube, V2 also in decimeter cube. Boleh faham? Okay, kita tengok. Kalau dalam formula kita V1 kita ataupun V2 kita cm3, V1 pun cm3. Dia mesti sama unit. Okay, our V must be in same unit. So until here, kita boleh faham tak? Okay, good. So now we know untuk kita buat 0.2 mol of the M cube of sodium carbonate, 100 cm3, kita perlukan 20 cm3 stock solution ataupun 20 cm3 1.0 mol per dm³ sodium carbonate. So kita dah dapat jawapan. Now barulah kita boleh buat proses. Okay. So this is pipette. Kalau tadi gambar yang saya lukis tu tak cantik, this is pipette. Tak ingatlah macam ni jadi. Pipette. P-I-P-E-T-T. So pipette pun is sama macam volumetric flask. They have their own, they have different sizes depending on the volume. So now yang ni kita ada 1 cm3 pipette. This is 4 cm3 pipette, 10 cm3 pipette, 15 cm3 pipette, 20 cm3 pipette, 25 cm3 pipette. Okay, so kita perlu guna yang betul. So now kita punya V1 tadi adalah 20 cm3. So which pipette should we use? Which pipette should we use? A ke, B ke, C ke, D ke, E ke, F? Good. So kita guna pipette E, iaitu 20 cm3 pipette. Good. Okay. So what should you do? Okay, so mula-mula kita pour first A, pour stock solution into a beaker. Itu A. This procedure are not in your textbook. So please copy nanti. I will give you this note. So please make sure this process are in your notebook. Okay, because they are not in the textbook. So we will pour stock solution into a beaker. Next, we will take out calculated volume. So how much calculated volume tadi? How much calculated volume tadi? Calculated volume yang kita kira. Yes, 20 cm3. So take out calculated volume of solution. So B take out 20 cm3 of stock solution with a pipette yang berapa saiz dia? Good. 20 cm3 ataupun selalu tak guna centimeter, ml. 20 ml pipette. Okay, remember juga bila awak tulis procedure, stock solution tu awak mesti tukarlah guna spesifik. So stock solution kita tadi apa? Tengok. Stock solution kita adalah 1.0 sodium carbonate. So mesti tulis dalam awak punya ni, tukarkan stock solution tu kepada, mesti tulis 1.0 mol per dm³ sodium carbonate. Baru betul awak punya procedure. Okay, so take out 20 cm3 of 1.0 mol per dm³ of sodium carbonate with a 20 ml pipette. So awak keluarkanlah. Ini guna pump. Pipette pun ada calibrated mark. So this calibrated mark tu sama dengan graduation mark untuk volumetric flask. Menunjukkan apa? Shows calibrated mark tu tunjuk apa? Sorry? Dah reach apa? Calibrate. Good. Already reach volume needed. Ataupun the reach volume yang volume pipette tu. Contoh 20 cm3. So kalau sampai dah calibration mark, cukuplah 20 cm3. Sebab sama juga pipette tak ada scale, no scale. Okay, just calibrated ataupun calibrated or graduation mark sahaja. Okay, so awak pun ambil lah pipette selepas dah pour stock solution dalam beaker, kita pun ambil pipette yang diperlukan and then kita pun ambil exact amount of pipette of solution needed. Next, apa kita buat? Kita dah ambil sirap, kita tambah air. So, kita transfer. Tukar sikit colour. The next step, we will transfer 20 cm³ of solution tadi, 1.0 mol per dm³ of sodium carbonate. Nak transfer ke mana? Into a volumetric flask. Volumetric flask kita berapa ml? Good, thank you. 100 cm³ volumetric flask. Inilah ayat betul dia. This is the ayat? Sentence that you should use. Transfer 20 cm³ of 1.0 mol per dm³ sodium carbonate into a 100 cm³ volumetric flask. Transfer. Dah transfer, kita buat apa? Mulalah dilution method kita. Kita add distilled water. So, add distilled water until solution level approach the calibration mark. Okay? Approach. Kenapa? Sebab kita kena berhati-hati. Kita nak berhati-hati nanti, kita kena tukar guna apa nanti? Ingat lagi tak last class, kita akan tambah air guna apa lepas ni? Good. Okay. Selepas kita dah add nak sampai calibration mark, nextnya kita akan add distilled water slowly with a dropper. Hampir-hampir nak sampai tu guna dropper. Okay, make sure your solution sampai at the meniscus at the calibration mark. Remember juga calibration mark tu mesti di bawah calibration mark. Meniscus of your solution mesti di atas calibration mark. Next, close the volumetric flask and shake well by inverting it several times. Okay, tunggang terbalikkan dia several times, beberapa kali, until the solution is homogeneous. Sampailah dia sebati ataupun selarut yang betul. Okay. Any questions? Dapatlah air sirap yang cair. Any questions? No, kalau tak ada question, saya nak tanya questions. What is the molarity of our air sirap ni? Molarity baharu. (0.2) molarity concentration 0.2 mol per dm³. Good. What is our new volume? Good. 100 cm³. So dapatlah awak a diluted sodium carbonate solution yang known concentration dia 0.2 mol per dm³. That is all. Itu sahaja cara untuk buat standard solution using dilution methods. So now, discussion. What is the volume standard solution? Kita kira tadi 20 cm³. Refer to the last slide lah. Refer previous slide. Okay, what is the size of pipette? Depends on volume 2. So in this case, the size is 20. It depends on volume 1. So the size volume 1. So the size is 20 ml pipette. Why is beaker does not suitable to use in preparing standard solution? Kenapa? Yang Anis Sharin cakap tadi. It's not accurate. We want to get accurate result. Accurate volume to get accurate concentration. Alright, quickly we are going through some calculation punya problem. Okay, so dilution always use M1 V1 equal to M2 V2. Kalau awak nampak soalan about dilution sahaja, terus ingat this formula. And you must also need to be able to identify which one is M1, which one is V1, which one is V2, which one is M2. Tak dapat yang ni, tak bolehlah juga guna formula. So let's look at the question. Figure 6.3 shows 75 cm3 of 2.0 mole per dm cube of nitric acid that is diluted to X mole per dm cube when 25 cm3 distilled water is added. Okay, maksudnya dia tambah 25 cm3. Calculate value of X. Okay, now kita cuba cari dulu apakah M1, apakah M1, V1, V1, M2, V2. Okay, what is our M1? Molarity before. Molarity before is 2.0. Good. So 2.0. What is our V1? Volume before. Good. 75 cm3. Saya tulis kat sini unit sebab kita nak bagi unit sama. So equal to M2. What is our M2? Do we know what our M2 is? Molarity after? This is our M2. Tak tahu. So X. What is our V2? Are you sure V2 is the volume? How do you get 100? Good. 75 cm3 dia add 25 cm3. So volume after is 100 cm3. Baca soalan betul-betul. Let's say kalau soalan tu tak cakap is added, dia cakap that is diluted to X mole per dm cube 100 cm3. Tak perlulah awak tambah. Bergantung kepada soalan. As long as you know that V2 is volume, total volume after. So now kita buatlah just rearrange our formula. So 2.0 times 75 divided by 100 is equal to, so our X is equal to, cuba tekan calculator, 1.5. Apa? Tengok balik, molarity. Kita punya unit for molarity is yes, mole per dm cube. Unit mesti betul. If you suddenly confuse, alamak unit ni mole per dm cube ke, gram per dm cube ke, centimeter cube ke, decimeter cube. Tengok, kalau M mesti di antara mole per dm cube ataupun gram per dm cube. Kalau soalan bagi mole lah. Volume pula mesti di antara centimeter cube ataupun decimeter cube. Tengok soalan dalam ni semua centimeter cube. Centimeter cube dalam soalan mole per dm cube. So mole per dm cube. So jangan confuse. Next one, last one. Boleh yang ni? Boleh yang ni? Example 12. Okay. Last one. Okay, determine the volume. Okay, dia nak V. So, kita tak tahu lagi V1 ke V2, tak tahu lagi. Volume of 2.0 mol dm cube hydrochloric acid. Okay, ini M. Kita tahu, tak tahu lagi M1 ke V1. Needed. Bila needed, kita tahulah ini 1. Ni pun 1. To be pipetted into a volumetric flask 200 cm cube to produce 0.2. Okay, to produce maksudnya final. Final 0.2 mol per dm cube. Mestilah molarity. Ini our volume after. So, bila dah cakap diluted, mestilah M1 V1 equal to M2 V2. Masukkan dalam formula. M1 2.0. V1 kita tak tahu. Equal to M2 0.2. V2 250 cm cube. Maka 0.2 times 250 divided by 2.0 is equal to berapa? 25 apa? Good. Centimeter cube sebab dia volume dan dalam soalan centimeter cube. So 25 centimeter cube. Any questions? Questions? No. Okay, so important. Okay, apa yang important? Identify M1, V1, M2, V2 correctly. Okay, mesti boleh identify M1, V1, M2, V2 correctly. Kalau salah, salahlah jawapan awak. So read the questions carefully. Satu lagi, apa yang kena penting? Unit. Good. Unit must be correct as well. Okay, so how? Macam mana cara untuk kita able to identify and give a correct unit? Do exercise. Inilah dia punya jawapan. Macam mana nak bagi boleh berjaya identify dengan bagus and tulis unit yang sentiasa betul? You have to do exercise. So that is why I will give you exercise for today's class. So today's class, you have to do your module, page 100. I also written the instruction for today's exercise in Google Classroom. But untuk bagi tahu dalam kelas ni je, module page 154 until 156. So homework, module page 154 until 156. And then textbook, calculation kalau saya bagi banyak, meaning it is important. Textbook, activity 6.9. Page, sekejap saya check. Page 167. Okay, so that is your homework. So please make sure you done your homework and send it in assignment in homework in exercise 8 if I'm not mistaken in Google Classroom. And also please make sure you finish this before our next class this Thursday. Why? Because we are going to discuss this homework. We are going to discuss the calculations in our next class. Okay? Boleh? Alright. Good. Thank you very much, everyone. If there are nothing else, please write down your name in the Google chat box and then you may leave this Google Meet.